Okay, let's start with the strength as a design consideration. Yeah. So strength is nothing but the load bearing capacity of the machine or of the product, whatever you are considering. Yeah. So this machine or the product should have sufficient strength to bear the loads, right? Say for example, you are going to design an automotive chassis. Yeah, you are going to design a car chassis for that matter. Yeah. So this car chassis has to take the load of, the passengers, okay, and the other components, okay, other components, and it should also take into consideration the cargo. Okay. So this automotive chassis or this vehicle chassis, whatever whatever you are going to build, okay, this has to have say for example you have the engine, so it should basically consider the passenger, and it should also consider the load, whatever cargo. Okay, so this is very important that you don't miss out on any of the load, because you calculate the strength based on your load. Okay, say for example you are designing designing a product for 1 ton. Okay, your strength is different. Now you are designing a product for 2 ton. Yeah, certainly your design may not be sufficient for that particular requirement. So you have to make sure you know you design the product with significant strength, considering all the loads into consideration. Okay, let's touch upon the rigidity. So rigidity is just opposite to the flexibility, right? So here we are telling that the product should be sufficiently rigid to have a linear or angular deflection within the limits. Okay, so it again depends on the product. Yeah, now let's take the same example of a automotive chassis, same example, right? Let's take an example of a car. Okay, so the car, okay, under the loading condition, the loads from the ground. Okay, so this would be also a load, right, while the vehicle is in the running condition. And then you'll also the net load, whatever we have discussed before. Okay, based on all these things. Okay, and your and the car is also in contact with the ground, at the wheels or at the tire. This is a point of contact. Okay, now with all these boundary conditions, the automobile or the car has to be stable, right? So the maximum deflections under this, so I can roughly model this, just for understanding purpose. Okay, as say for example there is a two support from the bottom, and then you have a support or the load at the top. So you have a support, say A and B are the supports, and then you have the load, Newton or kilonewton, whatever it is. Okay, now this will have certain deflections, right? Now what is the maximum permissible deflection? So this deflection I call as delta. Okay, so what is the permissible deflection? Max permissible deflection. So what is this maximum deflection I can allow? Okay, so certainly over the course of the operation of the product, the deflection should not exceed the maximum permissible deflection. Okay, so this is rigidity here.